All right, so in our part 1 video about generating girder point loads, we talked about this entrance element on our example building here. And in that previous video, we looked at generating girder point loads and performing a girder design when there's no deck and no area loads created in the model. So that could be for a preliminary design situation, or it could be if you're simply not performing that modeling for your particular project. In this second part 2 video, I'm going to go ahead and look at doing that same process of generating girder point loads, but for a situation where we do have deck or floor slab and area loads have been created on that deck, and I'll look at how we can use that to perform a similar design. So we're going to go ahead and look at this second floor plate here, and you'll kind of notice that this floor plate has been set up in two distinct areas. This smaller area in the corner here has larger loads, 125 PSF, so a light warehouse or light storage loading, and a 50 PSF dead on the slab. And then the rest of the typical area of the floor has some slightly lighter loads, a typical 80 PSF live for the occupancy, and a 30 PSF dead. And the girder that we're going to be focusing on in this demonstration is this girder right here that falls at the boundary between these two distinct areas of the slab. And the reason this girder makes a good example or a good study for this feature is because you're going to have three beams on one side that exhibit the lighter loading from the typical floor area, and then you'll have three beams on the heavily loaded side that exhibit higher reactions because of the more heavily loaded side of the floor. So in order to launch this calculation, we'll just do like we did before. We'll navigate to the ENERCALC SEL tab and trigger the girder point load tool and pick this girder. The first thing that it'll do is prompt me to confirm the supports, which, just like we talked about before, you can navigate and move around freely with the ENERCALC interface while you're evaluating that choice. Confirm the supports, and it'll go ahead and detect the tributary beams that connect to this girder. And when you confirm those, it'll build the reaction table. So what you'll notice about this reaction table that makes it different from the part 1 video is that instead of needing to manually input the area loads that you want to use for design, these area loads have been automatically detected because they already exist on the respective floor slabs on the two sides for the various tributary elements. So what we see here, if I pick on these, it's going to walk down the list, and so we see for the first three right here, we see the 50 and the 125, and then when we walk down the three on the other side, we see the 30 and 80. So these loads have been accurately detected for the distinct conditions in the various locations. And like we did in the previous demo, we can move around and navigate throughout these different views and see this highlighting at work in other views besides the 3D, and you can even freely interact here if you want to do, for example, take some measurements to verify the data reported in the table. And so we see that span and tributary information is accurate, the loads are accurate, and we can proceed with generating the reactions. The reactions create instantaneously. If any existing reactions were found, they would be removed prior to the creation of the new reactions. And once this is set up, I can simply go ahead and launch this calculation of the girder using the steel beam tool like we do for other calculations. And when this calculation loads in the ENERCALC interface, we're going to see that we have three distinct points where tributary beam reactions are applied on the girder. And if we go to the span loads tab, we see that we have 6 individual point loads as expected because we have 6 tributary beams. And so we have 3 beams that are showing higher reactions and 3 beams that are showing lower reactions. And we can verify that our capacity is adequate and go ahead and save and close this calculation. So that's your part 2 demonstration that shows how you can use that same power of the girder point load generator tool in a situation where you actually do have deck and you do have area loads, and take advantage of those to accelerate your design process for a girder.